There, 000. All right, perfect timing. Welcome. We have another episode of Get Energized now. If you know what that is, if you don't, welcome. Come join our program. This is our first session post reInvent, and so today's content. We had a couple of different approaches we could go about this here. In fact, if you're in Houston, there is which it's a long shot, but if you're in Houston, there is an energy recap that's happening a little later this week here. But we have an actual reInvent workshop that happened that will be demonstrated a bit here, and you'll get to hear it from the presenter herself. So pretty cool. Do you want to guess what I'm drinking? It's probably not that hard to guess this time.
Hot chocolate.
Oh no, you're wrong. That'd be energy from sugar. No, yes. This is purely cold brew. It's just cold brew. But it did work. I thought Rudolph might throw you off. It did. All right.
Yeah, it did. I got the caramel tea.
Caramel tea sounds good. How much caffeine's in that though? That's the question.
Good amount, because I put like 4 of them in there.
Yeah, okay. Respect. That's the way to do it. Okay, so I think we're good. I mean, it's nice to see everybody. It's nice to have y'all in, but let's just get Brittany in, right? What do you think? Get going. Let's see, Brittany. Get you added. There we go. Welcome.
Hi, Brittany.
Hello. Hey, everyone.
Want to introduce yourself? Then we can just get going.
Yeah, so my name is Brittany Harrington. I'm a solutions architect working with energy customers at AWS, and I am based in Houston. Just came from our AWS Houston office, so that would have been applicable to probably just me.
Cool. Why don't you bring your screen up here, and we'll just get going. I mean, would you want to give a little taste about what we're going to see while we get that stood up here?
You can tell us a little bit about the workshop.
Yeah.
Sure. Are you guys seeing my screen?
Yep, I got it. I'm pulling it up right now.
Perfect.
Hey, there we go. All right.
Yeah, so this is a workshop that we did at reInvent last week. So workshops at reInvent, they're 2-hour sessions, typically geared, they're hands-on. You're supposed to be builders. So it's all about the services and the technology, but you do it around a particular use case or business problem. So for us, we were building on a common thread that we see with customers across industries. So myself in energy, but my counterpart Krishna sees them in healthcare and industrials, manufacturing, which is using the cloud to automate and simplify manual complex processes. So the workshop is going to focus on one scenario to demonstrate the role of IoT in machine learning and process optimization, but it's applicable across many. So I'll just give a brief overview of the problem that we'll be solving, and then I'll dive into the workshop and actually show what we did at reInvent and what you're able to do if you go through the workshop yourself.
Brittany, real quick, I was actually going to ask something somewhat similar here, but we have a comment. So why combine IoT and ML for process optimization?
Yeah, so it's a great question. So with process optimization, a lot of the data that you're acting on, or the systems that you're interacting with, they're generating IoT data. So the quicker that you can be in ingesting that data and responding to it, that's where the IoT comes into play. Specifically industrial IoT, because a lot of times you're not connecting to greenfield assets where you're adding the sensors net new. You're connecting to an existing system like a SCADA or Historian. So that's the IoT component, acting at the edge, ingesting the data in real time and acting on it. And then the machine learning comes into play because the process that you've probably been doing historically has a lot of manual intervention. You're doing constant what-if scenarios. In our scenario, it's yaw angle optimization for wind turbines. So go ahead and pull that up. Basically guessing what is the optimal angle that we can offset our wind turbines so that the wake generated by the front turbines doesn't directly impact the back turbines. So we're slightly decreasing power in the front, but also increasing power in the back. And finding the optimal angles to accomplish that is typically a really manual process. You have to keep testing different combinations. So machine learning can come into play to automate that process, take the human component out of it, and continuously learn and improve on that. So we're responding quicker, and we're closing the loop. So that's where IoT and machine learning come into play. And we'll see that in just a second, looking at our architecture, how we're pulling in that data in real time, building the model based on it, and then deploying it back to the edge to act on new data as soon as it's ingested.
Great.
Yeah, so with that, I'll just go ahead and go into the architecture because I kind of gave a good primer there of what yaw angle optimization is. Let me just switch over my screen. Okay, cool.
Yep, we got it. I can see it.
Great. So this is the workshop that I was talking about. I shared the link with Lee. So
Yeah,
this
I'll put it in chat right now.
perfect. The workshop instructions are publicly available at this point in time because we did just come off of reInvent. To go through this workshop, you'd have to go through a member of AWS, so myself or another solutions architect, and we would provision a test AWS account for you, deploy the basic CloudFormation templates to build the starting infrastructure in that account, and then you could run through it on your own time. The goal for early 2023 is to make those CloudFormation templates public as well, so that you have the instructions and you don't need to go through an AWS team to deploy it into your own environment.
Able
So
to
for
do
now,
your own reInvent real workshop at home. Pretty cool.
yeah, on your own time. So yeah, for now, you'd have to go through us. 2023, it will be your own time, your own account.
But the directions right now are available.
Yeah, they're all in that link that I dropped in there. So you can start clicking. You can follow along while she speaks here, frankly. Yeah.
Yep. Directions are all on the link. It will take you to the main overview page, and you can walk through step by step. So the workshop itself is broken into 3 sections to demonstrate the combination of IoT and machine learning. The first section, and I'll give a demo of what to expect in each one. The first is going to be ingestion of industrial data from a control system using AWS IoT. The second is going to be actually using Amazon SageMaker to build a custom process optimization machine learning model. So you can step through the Jupyter notebook that we'll be using to do the exploratory data analysis, train the model, test it, and compile it for deployment. And then the third section will actually be deploying that model back to our gateway device and interfacing with it to test both prediction and optimization in a disconnected state. So while I go through each demo, I'll highlight the services themselves and why we made the technical choices that we did. And then if there's any questions, happy to go on a tangent and talk about them more.
I see it shows a AWS IoT Sitewise. Can you go into a little bit why you chose that?
Yeah, let me just jump into the first section of the workshop where we really focus on Sitewise. So Sitewise specifically is a good choice for industrial IoT customers. I went back to the customers that we typically work with in energy, manufacturing, industrials. They need more than just the ability to collect data from sensors and send it to the cloud. They also need the asset hierarchy that organizes and contextualizes thousands of sensors across fleets of equipment. So AWS IoT Sitewise is a fully managed AWS service that's designed to ingest, store, and visualize data from existing industrial data sources like SCADA and Historian. So I'm going to jump into my console to talk a little bit more about that and show you guys Sitewise. What you're seeing here, like I mentioned, is the console view that would be that you would see in one of the test accounts that we provision. So this is the same interface that you would work with if you were to go step through the workshop yourself. So in this example, we're ingesting wind turbine data from a simulated SCADA system that's running on an AWS EC2 instance, a Linux instance. I also have a gateway device that's also simulated on EC2 that's configured with IoT Greengrass and the Sitewise Edge gateway to continuously ingest that operational data from a fleet of 4 wind turbines. So what we see in the Sitewise, go ahead.
Oh, I was just saying that makes sense. Yeah, it's good.
Cool. When we see in the Sitewise console, so everything in our wind farm is based on the model that allows us to scale. So we have our model of a wind turbine, and that's where we define what measurements we're going to bring in. So for us, we're bringing in power, wind direction, wind speed, and yaw angle for each of the turbines connected to this control system. From there, we're able to create replicas of that model, so different assets related to a specific turbine. So we have 4 different turbines. 0 and 1 are going to be our leading turbines. You'll see that in the SageMaker piece in a second. And then 2 and 3 are the trailing ones. And if I just click on one of the turbines to see that we're actually pulling in data, we can see that the latest measurement for power, wind direction, speed, and angle was taken just a few seconds ago. So we can confirm that we're ingesting live data from that simulated SCADA system and it's flowing into our SiteWise console.
Is the GitHub link you sent me what's generating this data right now? If I drop this in chat, or is this?
The GitHub link is not. The GitHub link will be for the second part of the workshop.
Okay. I'll wait to drop that in there.
Yep, the code for the simulated SCADA isn't public yet, but that is actually part of another energy team project to make that code open source and public so that people can test SCADA on EC2.
Got it. Thank you.
Yep. So the other piece of SiteWise, besides the data collection and storage and contextualization, is the ease of visualization. So what we're looking at here is just a simple dashboard that I made in the SiteWise monitor, which is a way that you can create portals in the form of a managed web application and then use those to view and share operational data. And the benefit of this service or this feature is that you can build a near real-time dashboard without any coding. So engineers who understand industrial processes in depth but aren't necessarily developers are then enabled to create the dashboards they need without needing the AWS skill set.
Okay.
On the flip side of that, if you do have a development background and you're trying to build more complex visualizations or combine from different data sources, we have other services we'd recommend, like Managed Grafana, that you'd use in place of SiteWise. Yeah. The benefit of this service is it's directly linked to your SiteWise data store, it's near real time, and it's out of the box in terms of configuring the visualizations.
Makes sense. Yeah, it's hard to argue with that, especially for a workshop, right? You do that
Exactly. Yeah, the visualization in this workshop is just showing we have the data, what can you do with it? We have other workshops, other services that dive deeper into actually building digital twins and more complex visualizations than this. So I'll pause there. That's the first bit, which is just ingestion of industrial data. And realistically, you could end the workshop or a workshop there. That's a whole topic in itself. But for us, the second thing that we want to show is how to leverage that data. So
once you have that data in, how are you building that machine learning model?
Perfect. Glad you asked. So for the data science portion of this workshop, we're working entirely in SageMaker Jupyter notebooks using PyTorch. SageMaker has multiple interfaces, however, for different personas. So if you're not comfortable with a notebook environment, you can still build a similar machine learning model with low code and no code options. Ours is geared towards people who have some experience with data science libraries, who want to go through the whole process of data exploration through model deployment all in one interface. We're doing it entirely in SageMaker to give us that flexibility while making sure we don't need to manage the infrastructure, essentially.
I just dropped the GitHub link in here. We have some people asking about the machine learning components, everything, what's going on here. So if they want to, again, you want to follow along, take a look, at least make sense of this.
Yeah.
Check out those links.
And so the directions in the workshop kind of walk through screenshot by screenshot what to expect in the different cells of the notebook, and offer an explanation of what's happening at each step. I'll just kind of go through it quickly and show the highlights. I already ran through the entire notebook. But in the first one, we do everything up to training and testing the model. So we start, like I said, with kind of a simulated data exploration. And what we're reconfirming as a part of this is that there's a positive relationship between increased wind speed and increased power generation. And then the real takeaway is the last diagram you'll see, which is that as the leading turbines, so turbine 1 and 0 are leading, as the yaw angle increases up to 25 degrees, the leading turbine power decreases, but inversely the back power increases. So we spend the rest of the notebook and workshop trying to find this optimal midpoint.
So all the code up to there is to generate all of this here. It's step by step should you want to work through this.
Yep.
Right? Okay.
Yep. Step by step, all you would do is, and the instructions will tell you this, you have to define a place to store your model and any of the assets, and then just go ahead and run through all the cells. It will automatically go through the process of loading the historical data, training the model, and then you can step through step by step and just see what's going on and what are the outputs.
So in real life, this would have big implications because you can actually set your wind farm up and set how they're angled to create the most power possible in certain areas.
Exactly. Yeah, and so there's two bits to the first notebook. One that makes it powerful, and then one that makes it, I'd say, really powerful. So the first bit is just creating the power generation model, which we do with a neural network. You can walk through what the model design looks like and how we're setting the hyperparameters to allow it to train in a workshop setting in 2 to 3 minutes. But what you'll see by the time you create that first model is these first set of results. So, at a set wind speed and set wind direction, what's the power generated at each turbine? And we can see, based on the historical data set that we've generated, that for the leading turbines, we have about 1,700 kilowatts, and for the back, it's much lower. But when we offset the angle just with a sample number, 25 degrees, those numbers change. The front turbine power goes down, but the back goes up. So that's like reconfirming our initial hypothesis that there is an impact and it does matter what the leading turbine angle is. The second part of the first notebook is automating that what if process. So we'll use the SciPy library and run an automated loop between 0 and 25 degrees, however many iterations it takes, to find out what combination of angles leads to maximum power generation. So you'll step through that and you can read a bit more. We have some links to why we use these libraries, how you could build on this. And then at the end, you'll see, okay, we ran about 9,000 iterations, found that the optimal angles were 11 and 13 degrees, maximum power generated just under 5,000 kilowatts, and it only took 22 seconds. So that 22 seconds is really powerful because instead of running 9,000 scenarios, we did it in under half a minute.
So how does this
cool stuff?
How does this get into the edge components of the conversation that we're having here? So this is collected and run at that. What does the actual deployment of the model in this context look like?
Yeah, definitely. So the second notebook is going to focus, and I'll go through it much faster because this is where you really get in the weeds. And so I'd encourage, even if you just have the instructions, to step through step by step. Perfect. First, we go through the process of compiling the model using SageMaker Neo. So SageMaker Neo not tied to Greengrass or our edge environment.
Oh, did we lose Brittany?
So for our scenario, we're just going to optimize.
Okay. You're back. You're good.
We're going to optimize our model for a lambda. Okay, cool. I'll back up 1 second. Cool. So we're using SageMaker Neo to compile our model for any specific hardware or runtime. In our scenario, we're going to compile it for Lambda so that it can run on any operating system. And we do that because once the model is compiled into a Lambda, we can turn it into a Greengrass component, or really just a packaged Lambda that would run on our Greengrass software on the edge device. So that's what you'll do in the second notebook. First, you'll compile the model. You'll see the steps of SageMaker Neo, the API calls that we're hitting, and then you'll actually turn that into a Greengrass component down towards the bottom. So packaging it for deployment. And by the end of that step, if you were to go into the Greengrass console, which I'll do in a second, you'll see a component that is the packaged model. Essentially, it's just the model with the additional libraries that you need to run inference against it at the edge.
Real quick question, not to interrupt. I know you're kind of on a roll here, but so we had a question regarding metrics in near real time. Is that 1 second, 10 seconds, and then would direct connect or private VPCs affect the model performance?
It's a good question. I say near real time because it's not real time. It's not going to be the instant that an IoT message is generated. You see it in the Sitewise console. But it's always hard to give a specific latency because of the networking components that lead from your edge infrastructure to the cloud. So yes, if you're using something like Direct Connect, you're gonna guarantee a more consistent performance because you're controlling the connection, the bandwidth, you have less hops. So if you're using Direct Connect, it's gonna spin up. I've seen, and I've talked to my IoT counterpart about this, a couple milliseconds to get data from the edge into the Sitewise console. But like I said, it's going to be dependent a lot on your hybrid setup and how you've configured that from the edge.
Yeah, and that makes sense. We were working with field operations all the time. The connectivity is, that's the part of the challenge, right?
Yeah, and that's something that we can help you with, setting it up and making sure that with your restrictions, we're optimizing it to the best of our ability, but it's always hard to give a benchmark when it comes to IoT latency.
Makes sense.
Cool. So we'll just move into the last bit here so we can actually see what those components look like and how we communicate with them, the end result. One thing I want to highlight on this architecture diagram, so by the end of the second notebook, we have this one here. We have the machine learning model that's been compiled for deployment. Once you have that, it's great. You have a model at the edge, but you don't have any way of interfacing with it or communicating with it. So we create 2 custom Greengrass components in this third section as well. And the code for these components is actually in the GitHub repo, the same one as the Jupyter notebook. So you can dive a little bit deeper into the optimizer and predictor and see the scripts, the Python scripts. But so we have one component that is responsible for prediction, the what if scenario, and one that's responsible for optimization, the automated loop. And what those components are, they're also, packaged lambdas that were a Python script. They're going to take the MQTT message input, format it to be sent to the machine learning model. In the case of optimization, it's also going to run that in a loop, get the result, and send it to the end user. So we need these 2 components to actually be able to communicate with this model at the edge. And once you go through the third section of the workshop, that's what you'll see here. So we have our compiled model, and then we have our predictor and optimizer components that are also running on our Greengrass device and able to communicate with one another.
Yeah, very cool.
Yeah, I'll show what to expect at the end. We're communicating by using MQTT topics. So if I go back to the architecture, the predictor component and the optimizer component both publish and subscribe to their own topics. So that's what you'll see in the test client. For the prediction, it's going to be the predict result topic path, optimize, very similar. If we send a test payload to each, for predict, we'll say, at this wind speed, this direction, and these 2 yaw angles, what's the expected power, just like we did in our Jupyter notebook. And we see the responses. They should look pretty similar to what you saw in SageMaker in section 2. And then for the optimized result, that's where we just give it the wind speed, wind direction, and max iterations. And we should get the optimal angles back. And so I think I still have, the input open for optimize. I'll just do another message so we can see 12:25, it's running. A few seconds later, we get the result. So in terms of latency, like I said, this is all running on a simulated EC2 instance, but that was 4 seconds from when we sent the message to when we got the results.
Yeah, no, that makes sense. The lab environment and context, all this anyways on top of it. So
exactly. And it's also triggering the model in that time to do the optimization. So it's a very quick turnaround.
Yeah, no, that's very fast. So
yeah, exactly. But yeah, that's about it. So I'd say going back to the first page, workshop has 3 sections. First is ingesting the industrial data, storing it in Sitewise, contextualizing it, visualizing it. Second part, using historical data. If you were to run the Sitewise, the SCADA integration long enough, you would generate your own historical data set that you could use. It's a workshop, so we don't do that. But that's training the model and compiling it for deployment.
Yeah, so you can absolutely take steps beyond this if you want to work
exactly.
through this.
Yeah, and once these are available in your own environment, I'd encourage you, play around with it. What other visualizations can you do? Can you do the SageMaker steps in a different way? There's a lot that you can do beyond just the demo workshop.
And Brittany, you said this could be used in other ways other than like the wind farms. There's other areas that this can be used in.
Yes, we actually have other examples in a workshop setting as well. Like we have a similar one for set point optimization for chemical tank reactors. Similar state where you need to run that in an AWS environment. But say we have workshop examples and relevant blogs as well. But beyond that, it's an applicable example to multiple industries, multiple examples, because it's just the loop of IoT, machine learning, doing that at the edge. You can do that in 1,000 different scenarios.
Yeah.
Yeah.
Totally fair. No, it's very cool though. And so the big takeaway again is 2023 sometime here. This reInvent, this will be out for anyone to do at any time in their account. So.
Exactly. Yeah, and we'll publish that once it's published. We'll make sure that people, both energy customers and non-energy customers, people that are just interested in IoT and machine learning, know that it's available and how to access it.
Awesome. No, really cool. Brittany, thanks for repping energy IBU here at reInvent and putting on a cool workshop like that.
Totally.
Thank you so much, Brittany.
Appreciate having you here.
Guys, thanks everyone.
We'll see you.
Bye.
Okay, that's the show. So what is it now? It's middle of December, so holidays are coming up. We will have one more end of year special.
We're getting one in before Christmas.
We're gonna fingers crossed. I don't know if you got to catch the Halloween special, but if not, encourage you to go look at the VOD. It was fun. We're gonna try to do something like that for Christmas as well. We'll see how off the rails it goes. Hopefully pretty off the rails. It should be fun. But if you liked this, again, I'm going to really quickly drop the links in just in case anybody joined late and wants to look at this. This is the workshop that Brittany was showing. And this is the GitHub to the ML components. Hey, welcome. Like seeing the hands up. All right, cool. Looks like people enjoyed it. I think it was a great session. Very, very cool stuff. So we've had a lot of feedback come in, directing us towards a lot of the IoT, larger industrial conversations from our show so far. So keep sending us feedback if you like this stuff. Glad to hear it's cool. That's wonderful.
It's good to hear. Yeah,
we
had lithium last week and this week.
So keep letting us know what you like. If you have any other ideas, but yeah, the Christmas special should be a lot of fun. We'll find out what that entails. Anyways, if stick around, it might be recorded in Christmas. We'll see. It probably will be recorded. So this might be our last live hello, and everybody have a good one.
We'll show up.
Ransomware. Oh, okay. I if you could go look at our old sessions in the videos on VODs here, we have I did a fault injection session in one of these that you might want to look up. So that was if something went horribly wrong. But ransomware. You're giving me an idea. We might mess with that. That's a good thought. Okay. Obviously not running ransomware, right? I think we will recover from it. But anyways, thanks for coming in, Dan. Anything we should say? Make the shot. Come on. Make the shot. He has
one of these times I will hit it.
It's on video. He's done it before. Anyways, all right. Take care. Be well. We'll see y'all later.
Take care.